Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss one important concept for solving string related programming question. So you know our English alphabets are having only 26 letters A to Z. Okay, ignore capital and lower case, that is capital and small letter. For the time being I am just talking A to Z. If you consider, then there are basically 26 distinct values possible. Okay, so now what you can do, these all the characters have their ASCII value, like capital A is having 65, capital B is having 66, capital C is having 67, and this particular character can be used same like integer for defining the index position of an array. Suppose if you are writing small a, which is one array of capital A like this, then this will nothing but indicate indication of A of 65, okay, which will indicate the index position 65 of the array, because capital A character is indicating 65, right? Because you know ASCII value of A is 65. So this particular property, that characters also can be used for indexing, we can use for this particular property, we can use for solving lots of programming question. Only we require one integer array of 26 length 26, and here we will store the frequencies. What we will do, suppose we are having a string b equal to abcd ca, so a is having frequency 2, b is having frequency 1, and c is having frequency 1. Now we need to find out these frequencies in one traversal. What we will do, we will start traversing from the left hand side. Now we can write code like this. Understand it very carefully. I will show you the dry run also. So for int I equal to 0, I less than b dot length I plus plus, and then here what we can do, a of b dot char at I minus 65 plus equal to 1. Okay, that same formula I have basically written here. Okay, so you have to define this one before this particular code. So see what will happen. Start traversing. Suppose capital A will appear. So a of b dot char at I minus 65. Okay, so why I am writing like this? Because our array is having length 26, right? So 0 1 2 3 4 5 6, like that it will go up to 25. So we have to write such code for which 0 index will indicate the frequency of capital A, 1 index will indicate capital B, 2 index will indicate capital C, 3 index will indicate capital D, and so on. So what we can do, see, A is having 65 value, right? So B dot char at I minus 65. So if you write like this minus 65, what will happen? This is nothing but A of 0, right? Because capital A is 65. So A of 0 plus equal to 1. Initially when you are defining this particular array, obviously all the values are 0. So this particular code nothing but short form of this one, A of 0 plus 1. So what will happen? 0th index position will be incremented by value 1. So our new array will be basically, if you consider the index position, initially all the values are 0, right? Let me write 26 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. Okay, just let me count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. All right, now when you are doing A of 0 equal to A of 0 plus 1, the 0th index will be incremented by value 1. Okay, and rest all will be remaining as it is. Okay, so new setup will look like this. Then what will happen? Then when you are traversing to the B, so B, what will happen? Same, A of B dot char at I minus 65 plus equal to 1. That is A of, what is the B value? That is 66 ASCII value. So 66 minus 65, that is 1. So A of 1 equal to A of 1 plus 1, it will happen. What is previous value of A of 1? That is 0. So that will be incremented by value 1. So this will be looking like this. Okay. and this part will sit as it is, right? Then next, what will happen? We will come to C again. C is having value 67. So 67 minus 65, that is a of 2. A of 2 will be plus equal to 1. That is a of 2 will be incremented by value 1. So 1, 1, 1, and rest will be as it is zeros. Okay. So here we can simply paste those, and then again A is appearing. A is having value 65. So A of 65 minus 65, there is A of 0 plus equal to 1. There is A of 0 equal to A of 0 plus 1. A of 0 is already 1, that will be further incremented, so value will be 2. So 2, and then here rest will be as it is. Now you just observe what we got at the final array. The final array is having all the frequency values of all the characters. Okay, like here capital A is having the frequency 2, capital B is having the frequency 1, capital C is having the frequency 1, and rest all are having frequency 0. So this particular concept can be used for getting the frequency using array instead of using hash map. You can use hash map, but instead of hash map you can use this one. And suppose all the characters are small letter characters, what you can do, instead of subtraction by 65, we can subtract by value of small a, which is basically 97. Here you can check, small a is having value 97, right? So here you can apply that. So instead of minus 65, you can subtract 97. That's all. Simple change, right? So based on this, let me show you an example code. So the question is this one: valid anagram. Given two strings S and T, write a function to determine if T is an anagram of S. Input S, suppose anagram, T is NAGARAM. What is anagram? Basically anagram is basically one string and permutation of other string. Okay, so see, all the characters present here are same here, just this particular T string is permutation of S, so output should be true. Suppose you are having rat and here car, car. These two are not permutation of each other, because here C is not present, but in the second string C is present, in the first string T is present, in the second string T is not present, so output should be false. And note, it is given that you may assume that string contains only lowercase alphabets. Okay, so what you can do for solving this particular problem? First stage is using the character indexing concept. This you can conclude as character indexing concept, because we are using characters for indexing. So using character indexing concept, what we can do? We can basically first get the frequency of the first string, characters of all the characters of the first string, and then we will traverse in the second string, and while traversing in the second string we will subtract value 1 from the character array, from the array what we have got, which is basically storing the frequency of the characters. Like here initially we were doing a of b dot caret I minus 97 plus equal to 1. While traversing the second string we will do minus equal to 1. So as a result, as both the string is having equal frequency for same character, after performing this minus operation for the second string, all the values of the array should be 0. Okay, if it is 0, that is anagram, else that is false, that is not anagram. So here is simple code like class solution and public boolean is anagram string S and string T we are passing. This is a function code where is anagram is our function name, and we have to return boolean output, that is true or false. Then int a equal to new int 26. 26 I am taking because it is clearly written all are lowercase alphabet. Okay, then string inp1 equal to a, string inp2 equal to t. I am defining these two strings with these two values. So what you can do, you can directly use s and t for traversing also, no issue in that. And then we are creating the frequency array using character indexing. For int I equal to 0, I less than inp1 dot length I plus plus a of inp1 dot caret I minus 97 equal to a of inp1 dot caret I minus 97 plus 1. So what I am doing here, I have shown you the short form notation, that is a of b dot caret I minus 97 minus equal to 1. Rather than that, I have just written it in original form so that you can understand it easily. And why minus 97 instead of minus 65? Because this is lowercase alphabet, right? So we have to use minus 97 because 97 is the threshold. Smallest starts from 97. So to convert all the index from 97 to 0 index, we will subtract 97. Now we are adding plus 1 to get the frequency for INP1. For traversing INP2, we will basically subtract 1. Okay. And then we will check whether any element of the A array is non-zero or not. Okay. So int g equal to 0, and then for int I equal to 0, I less than 26, I plus plus. If A of I not equal to 0, g plus plus. We will increment this variable. Okay. Then if g equal to 0, that means that is anagram, so return true, else return false, that is not anagram.